Okay, audio check. 1, 2, 3. We're good. So, ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy. We are building a game with no game engine. And so, it's a simple game, but we're adding some little bits and bobs here and there that are kind of fun and interesting. And we're in the wrapping up stages. I've got 2 more bits and bobs to add, some cleanup work here and there. Which I probably should note. Some optimization on memory, on space. And the rest of it's basically the marketing, the storefront, the logos, the images, which I'm not very good at. I was working on that more today and spent, probably an hour on a graphic because I'm not a graphics designer. And then it doesn't work. Sasha Albert, how are you doing? I just followed. Yeah, welcome, welcome. How are you doing? Let's see. Sasha, that reminds me that I'm not a variety streamer, I'm a programmer. All I do is programming, unless I'm sick. Then I'll stream a game or something. So I did The Witness once, but I haven't really been sick that often, so it's just programming. That's basically it. Doing good, good, good. Yeah. And you, what are you doing here? What's your interest? Make sure everything's coming up here. That looks good. Looks good. Okay. Doing good. Good, good. Glad to hear it. Glad to hear it. So, where am I at here? Yeah, so I was trying to do some graphics for my Steam store page. Got some work to do there still. This one I don't think actually changed anything. So, oh no, that makes sense actually. Okay, so I renamed this file. That's all that is. So let's get that committed. Steam store graphic. So that's the kind of thing I'll do off stream sometimes. If you look at the old journal, yesterday we finished up the doodad for Robert of Locksley. And today we're starting, so let's go ahead and crank up today's to-do list for our tasks. Which we still from the to-do list. We're gonna do the solar system chalk doodad. So that's great. What more games do you play? I did The Witness. I play in my own time. I play Slay the Spire, Enter the Void. I quite like roguelikes, so like Dead Cells. Darkest Dungeon was good. Not really any first-person shooters. I played Grim Dawn, a little PoE back in the day, but it's been a long time. Yeah, but mostly I'm here to program. So, what games do you play? What do I do besides streaming? Well, let's see. Besides streaming, mostly programming. Like, I don't even think of myself as a streamer. I think of myself as a programmer who happens to stream. So, even if I'm not working on stream, I'm working off stream on something, personal projects and whatnot. So, but this is the first time we're building a game with no game engine from scratch. Can I ask you something? Sure, go ahead, shoot, ask away. parametric ellipse from 2 points, fake depth. Hey, G Panelli, how's it going? I play a Minecraft, Roblox, Call of Duty, Warzone. Okay, cool, cool. I never played Minecraft. I did quite like Terraria, which is like a 2D Minecraft, you know, lots of digging and harvesting and crafting, so that's good. Roblox, never played Roblox. Call of Duty, Warzone, yep, never played Call of Duty. I just don't have the reaction time. I've spent too long sitting very still in a chair looking at text to be very good at first-person shooters or fast Twitch games. About me, I just do custom network arts for streamers. It would be great if you can check out some of my recent work and give feedback on my work. It would be really appreciated. Make something cool for your channel, can as well. I think it would be cool to get new art, but I don't have any money. I'm running out of my savings, so probably not going to be commissioning any new art anytime soon. And the stream doesn't make any money to speak of, so probably not worth it at this point. Really enjoyed watching your stream. You're doing great work here. Thanks. You make my stream even better, and well managed. I have a good idea for that. Would you like to hear it? If you had me on Discord, I'll show you some of my recent projects. What do you want to get made for your stream? I could a lot of other things too. Logo, banner, panel, 2D art, etc., etc. Oh, okay. Well, sounds like you're a very graphical person. This game and this stream right now is not in the needing new art phase, and we don't have any funds for that. I run a fairly large household, and I'm running on my savings. So until we make real money, probably not doing new art anytime soon. But if you send me your portfolio, then that is something I don't mind looking at and keeping in my back pocket for when I do start making real money. G Pinelli, doing fine, good, glad to hear it. How is the game doing? The game is good. We've got the Archer done. We're no more Archer. We're going to do a solar system on the chalkboard. We'll do some stars, maybe a nebula. We'll do some different things on there. My prices are reasonable. Pay me installment, also bi-weekly. Yeah, but I have no income, so if there's no revenue, like I try to keep the expenses to 0. Basically, all of my work is free right now, so really don't have the money for that kind of thing just yet. Like I said, happy to look at your portfolio and keep it in mind for future, but right now, not spending money. Planetary depth. Another thing we might want to do, asteroids. Those are part of a thing. Yep, I am a paid artist. Yep, and I am a not paid programmer right now. Okay. So that's the plan for today. I have a couple of other ideas depending on how fast these things go. So if we go into our code source, chalk, solar system. Except I can't type today. Got to warm up here. Doodad chalk solar system.hpp. There we go. We get the doodad chalk ball. HPP. We're gonna need some of this. We're gonna need math for sure. We're gonna need most of this stuff. We're not gonna take the mouse yet. I don't know if we need a mouse for this one. Input, I kind of want to. Scheduler, maybe not. Sound, can't think of any. There we go. That's what we need to get started. Can give you my disk Yeah, I have a Discord server that's pretty quiet. Just my announcements. Feel free to pop in and yeah, let me know. Why is asset loading and GPU buffer such a hard thing? You know, GPUs kind of have this problem where because they're so specialized, each GPU manufacturer kind of got to determine its own interface. So there's no like there's no single way to do it, and they don't play nicely together. So what is out there is not optimized for programmer developer efficiency. It's optimized for the GPU itself. And GPUs are inherently complicated, so that's a further point, I'm afraid. Because there's a lot of things that happen on GPU. Even assuming a fixed pipeline like old style OpenGL or the default out of the box OpenGL, it's still complicated just to get those performance gains for the highly parallelized tasks. But when you start building your own pipelines, it's a disaster. Asset loading, GPU buffer, such a hard thing. What are you using? Are you GFNL? You were using SDL or OpenGL? I don't think. Well, for the simple use cases I'm doing, the GPU buffer usage is pretty simple. I have my vertex buffers, I have my texture buffers, and that's basically it. I don't do much. None of the fancy stuff. I don't have stencil buffers or shadow buffers or anything like that. I'm not doing physics-based rendering. That's right, WGPU. And I know less than nothing about WGPU specifically. Yep. Assets are tricky. Like, there's so many formats and encodings that have to be supported. Like, if you say, I support JPEG, well, you probably just imported a large JPEG library. If you want to support PNG, again, you probably imported a large library with it. Although, I found a single header file PNG parser that I really like. It's no real dependencies. Just a lot of boilerplate. Yep, where to keep things. Yeah. It's all about the bookkeeping. Keeping track of what's where, what its status is. A lot of boilerplate. Yeah, that's fair. Yeah. That's fair. Which I think is one of the reasons that a lot of people go with the game engine, right? It's hard. It's hard to write a game. They just want to have it be faster, easier, simpler. All right, let's start with a simple quad. We're going to call this one the sun. We need bounce checking. Probably. We don't have gravity, damping, elasticity, mass, force, velocity. Contains update position. I think that's mostly it to get started. Yeah, keeping stuff hidden is why engines are good. Yep. But having things hidden is also bad. There's a trade-off, and when you make that trade-off, you should understand what that trade-off is. When you build your own game and you have every last detail in your head, you can optimize the heck out of it. Because you know what it does, you know what it needs to do. When you make a game engine, you don't know. you have to support everything. So you make decisions, and everyone else has to live with them. There are optimizations you cannot make because of how generic it has to be, and then it just goes from there. But to get something on the screen, much faster to use an engine, 100%. But for the amount of control, game engine is not as good. You often end up with people writing wrappers. Like, I was just listening to one guy who was optimizing for large numbers of entities in, I don't remember, Unity, maybe? And they basically wrote their own object model on top of that one so that they could optimize how it accessed the entities, right? So, trade-offs. If you have to write portions of the engine over the top of the existing engine, did you really save much? Yeah, I don't know. Okay. Okay. We're going to start off with one child. It's son. I think that's it. We're going to start off default not enabled. Blah, blah, blah. We need a fade in, fade out. We need an update function. We need a render function. Set bounds. And I think nothing else is needed here. So we're just stubbing things out right now. Well, so I have a problem with layers of abstraction. I think they're taken for granted too much. If you go back to The Humble Programmer by Dijkstra, there's a great quote in there about abstraction. And a game engine is an abstraction. It's a whole lot of abstraction. Here you go, a little light reading. This is 1972. Let's see, where is it? Trying to find the quote here. Here we go. This is the quote. Great quote. Boom. The purpose of abstracting is not to be vague, but to create a new semantic level in which one can be absolutely precise. Asset loader to load images on the CPU. The game engine is basically an abstraction of what you need the GPU to do. Yes and no. Depends on the game. You also have, physics, asset handling, networking. It can add a lot of abstractions. And I like the abstractions. Like I do not want to write binary code for GPU, but I wish that the abstractions that the GPU language developers had chosen were better, right? The fact that I have to be so knowledgeable about so many different kinds of graphics cards and what's supported and what's not supported. Like there's no convenient layer in between that would make it even easier. Like there should be better abstractions chosen. I don't know. I already have an asset that has doodad type things in it, so I guess we'll just use that file. So let's go over to. Oh, I already have GIMP open. Look at that. Let me load up the background and doodads file. We just got our little dude from last time. Let me open up assets, images, background, and doodads. There's a lot of empty space here. So we've got the bubble, we've got the ball, we've got an airplane, all good stuff. So we need planets. We need a sun. The big yellow one is the sun. So let's put some guides down. And we're not going to worry too much about proper scale. The solar system drawn on a chalkboard would just be a couple of dots, would not be interesting. But we do want some at least relative scaling, right? So the sun will be the biggest one, maybe, let's see here. For sure, but it's impossible. The more you need power, the less abstracted it can get. The same goes for the design that Laravel likes, convention over configuration. Yeah, anything that has to do with GPU is configuration over convention. Yeah, well, the whole mission of the GPU interface is you dump memory into a place and then we crunch it, right? So it's all about copying the right data into the right place and explaining to the GPU what it can and cannot do with it. Or should and should not do with it. Okay, so sun. We're at 2024 is our, or 2048 is about here. So if we want a, what, 64 pixel sun? Or 2048. So about at 1948, that's 100 pixels. And then another 28 pixels less than that. 1920. So is that going to be our sun right here? We'll draw the sun there. Yeah, data, do thing, result. Yeah, and 90% of your time with data is spent copying it. 1920. So if I make a sun there, paintbrush, grunge, 16. So this is as big as our stuff gets here. New layer. We want the sun. Because we really don't have that much room on the chalkboard itself. So if we get an ellipse, no, not center. This one. Actually, that's fine. Just gonna go from here to there. Ugh. Yep. Alright, ellipse tool. If our brush is 16 pixels, it would come in 8, 120, 116. 116. Then we add 16 here, so we're 28. Yeah. One 28 to 116 is 12. 128 minus 16. That looks more centered. Okay. And then we want a nice, so the sun starts off with a nice orange. Okay. Then we're going to shrink this by another 16, so that's 94, 94. And then we're going to add 8 more to this, so 36, 19, 36. Oh, pardon me. 94. Let's go with another 8 off that, so 86, 86. $40, that's about centered. Then we choose a different color. We just move up towards yellow. Okay, let's do it this way. This is 1920. Okay, math. Where's my calculator? 2020, no, 2048 minus 64. 1984. $1984. 1984. So that's the center. Now when we select, we can expand from center. Now we were always centered. Right now we're making it, let's go to 94. Let's just try it. Stroke the selection. Yeah, that looks pretty good. Okay, then we chop off another 8, 16, that's 94, 86, 86. Maybe 282. Oh, no, come on, kid, stop being silly. 78. Yellow. Okay. Now we shrink it some more. So let's go to 62. Now we just want to fade towards white. Okay, minus another 12, 16, 62, 52, 46. Choose an even lighter color. And then lastly, 30, 30. Basically we want white. Although maybe we just go full white. Let's go 12. There we go, there's our sun. That's what I've decided. That's not terrible. I've seen worse. Layer, crop to content, and there's our sun. That's identifiable, right? Okay. Okay, so see here. Finally, I got loading image. Yes, and a cache with handles done for images. Good, good. Are you looking up by like an ID or by string name? Like a string dictionary? Good. So are you loading PNGs, JPEG? Both, all of them? Trying to actually use it in a simple renderer. Yep, one step at a time. Load your data, then draw it. Okay, so there's our sun. I'm going to do one thing to the layer. It needs to be wider. There we go. There's our sun. I probably should look up planetary radii, but we're not going to today. Or at least, not right now. Let's just get the sun showing up. So we export as background and doodads PNG. Agreed. And it's a big texture, so we can fit all of our planets and a few other things in here and not have any problems. We need to export the UVs from the layers, and that's it for that. So in here, images, background and doodads. We need tools UVs. This is what was last out exported. Right here. Let's reload it. Oh, we didn't finish the export. Hold on. Okay. There we are. Replace what we had with what we've got. Okay. I think that's it. Now, embed PNGs. Directory might have been in. Oh, good. Okay, exit. Oh. There we go. If we're in the directory I expect to be in, it'll be way easier. Dun, dun, dun. It's just a U size, basically a unique U size is used to get any asset with it. Okay, okay. The naming is not that good as I have a texture that loads images, so I can do get texture, handle image, but it works. Okay. Now I will ask ChatGPU for naming ideas. There you go. See, and that maybe is the kind of thing that ChatGPT is pretty good at. I actually had a is like, hey, what's a name for this, or what's a good mnemonic for this? That might be something that's useful for. Actually, my brother-in-law was memorizing a bunch of stuff, and he's like, "Hey, ChatGPT, I have this list I need to memorize. Can you give me an acronym or a mnemonic for it?" And it apparently was pretty good at that, or at least good enough. So, okay, solar system. What we're gonna do is we do this. We take sun. We get the size of the sun, width, height. That is not correct. Sun, set center, underscore sun. So there's that. Fade in, we're not going to fade anything just yet. And same with fade out. Not yet. Update. If enabled, we're not going to do anything. That's fine. If render, draw the sun. Set bounds. Set the rectangle. Maybe the archer set bounds is the best place for that. There we go. Yeah. So I'm going to store some areas, set our rectangle, and that should do it. And then we're going to set the sun. M underscore sun move to r dot x, r dot y, no, r dot width over 2, r dot height, multiply 0.5. For me right now, that's the easier number, 0.75. So it'll be 75% of the way down. Render, update, fade in, fade out. Okay, make file. We gotta add this all to the make file. Archer, solar system. There we go. So now we tidy up and debug and see what happens with that. I have to go and I'll be back later. Sounds good. Sounds good. See you when you get back. Okay, so this build will take a minute or two. I don't know if I want to have the planets rotate at all. Different options. I don't think we will for starters. Okay. Just filling things in. let's go to game context. We will need something doodad related, I thought. Number of chalk doodads will be 3. Space. Game scene. Archer. Solar system. Maybe we'll go rename that. I don't actually like that. So I think we're going to do more than just the solar system. We'll have the solar system. We'll do other things with it. So let's go to we're going to rename file and buffer to doodad chalk space. Rename file and buffer doodad chalk space. And we'll rename we need to do this to everything. Space 1, 2, 3, 4, 5. There we go. Game scene. I'll do make file. There we go. Okay, now game scene. Everywhere the archer shows up. We put space. Oops, whoa, come back. Set bounds. Space. Space. That's basically it to get it plumbed in. So basically that should be enough to get us one thing on the screen, and then we'll come back around. Whew. And add more things, but we'll only have to add them to the one class. It's all plumbed into the game scene. We'll probably do the fade in earlier, so that as we add elements to the thing, it makes sense. It's an easy place to add. I think we'll just fade them in. Okay. And quad is actually the sun for now. This is actually going to be reused so many times, we're going to start abstracting this away soon. Permission denied. Oh no. I think it's opened by me on the other account. There is a way for me to Windows Task Manager. I should be able to kill a process run by another user. Details. It's not gonna let me, is it? Okay, we're gonna cheat then. We're just gonna work around it. I don't want to interrupt the stream, and this is rather silly. I'm just gonna output it towards Sleuth 2 for now. We'll come back around. Hey, AK Elements, gonna hang around here for a couple minutes while winding down. Oh sure, yeah, no. How's the render graph stuff coming? You said you were gonna wrap it up today, but I know every time I try to wrap something up, there's always a long tail of loose ends that I gotta get through. Okay, so we're gonna run our program. So what we're working on is the chalkboard has different doodads that you can interact with, and there's our sun. That's actually huge. It's too big. Because if we put the whole solar system down here, well, the sun can be pretty big. But it's showing up, so that's progress, I guess. Yeah, I did not manage to get it all done. Good progress. Yeah, good. Good to get that progress in. It's looking good. It is looking good. Okay, so we're just gonna fiddle with this for a little bit then. The space. So I moved the sun within the chalk. I'm thinking the sun might just be too big. So this rectangle is the dimensions of the chalkboard that we're in. Then we want to move up off that bottom edge by the height of the sun. That might be more than I need. Well, let's just try it. Easy to try. Yeah, so I have the game is more or less done. I've got some loose ends and optimization on space, things like that to do. but we're doing little chalk doodads that we can interact with just as a way to fidget, right? I always liked that about Hearthstone. The world was interactable outside of the game itself. Yeah, this is way too high. Okay, I know what I'm probably going to end up doing then is a combination of things potentially. Because I'm going to have to scale the sun down more. Nice touch in Hearthstone. Yeah, so we've got 3 done. We've got 2 more I kind of want to get to. They're all on the chalkboard. So we're going to have like a little solar system with the planets going around on the chalkboard. Some stars and nebula, that kind of stuff. There's the sun. So we have to limit all the planets from going below that line or above the sun by very much. Or we have to shrink the sun. But we have other ones we can play with, and we'll make a little way to switch between them later. So if I go to game context and just change the default loading in one space to ball. Well, this also lets me just play with game systems that aren't part of my game, right? So I've got like little physics and colliders and collision resolution. They're not good, but they're like little prototypes of complex systems that we'll build later in future games. So like here's the ball one. It's got a bouncy ball. If you right click, you can interact with most of the doodads. So you can throw the ball around. That's kind of cute. Then we've got bubbles. This one has more collision resolution involved in it. Like we do preservation of momentum based on the radius of the bubbles. And again, not optimized at all, but just the small prototypes of more complex systems. So in this case, all the bubbles show up, and then they just sort of float around and bounce off of each other. You can pop them with the right click. Like I said, just little things to interact with while you're thinking. Then we spent like the last week on the most complicated one. I underestimated how long this would take me, but we built an archer on our chalkboard. And so these will, when you load into the level, these won't be showing up. And then there'll be a button to click that'll create the next doodad in the order. And then erase the current doodad. So that you can cycle through them if you want. Find your favorite ones. But here's the archer one. Go golf mode. Doesn't matter. Here's our little archer. And if you can walk him around, right click him, and you can shoot the arrow. So if you miss the target, or if you hit the target, oh, you don't get a score unless you're out past the orange one. But if you move out further, you get more points. So that gives you a double bonus. That one gives you triple. And the fun part is... Oh, I missed. Okay. Then you can retrieve your arrows. Retrieving an arrow resets your score. And then our little dude can accidentally shoot himself. Just for fun. So yeah, those are the 3 done ones. We're going to do a little solar system today. Really nice UI and animations for the scene transitions. Thanks. Looks smooth. Yeah. Yep. So just fun little Easter egg type things for people to play with. So my to-do list is getting shorter. Like I've got some cleanup on that. So the Archer cleanup wave animation. It doesn't look good, but like just little tiny things. A couple of bugs. The replay's not working right now. We're probably gonna be done with doodads. We're not gonna get to all these before we ship. Art's almost done. Songs are getting there. So yeah, we're actually getting pretty close on things, which feels good. I think the end is in sight. Probably not. I doubt I can get it shipped this year, but in January, maybe. Space. So back to space. I might just put in a scale factor. Static const float. 875. We'll just shrink the sun up a bit. Just shrink the sun up a little bit to see if it fits better. We don't have a lot of space to interact with here, so const expert. Okay, fine. So I think we'll probably put a field of stars on the chalkboard. We'll probably put a nebula, put a bunch of planets on there, have the planets move around the sun. We're gonna fake it all. This one is not a very stateful doodad. Okay, so there is a little bit more room now. We do want the sun to be large compared to everything else. Let me think. I want to move it up, but I don't know how much. Maybe we just say we move up half our height and then another eighth. So maybe like 0.625. That's math I can understand when I look back at it. While we're at it, let's do the fade in. Create an animation. Give ourselves a second is fine. We're gonna go from 0 to 1. Give them a floating point value. And we get a color C equals underscore sun dot color C dot alpha. Let's see, we're gonna int alpha equals our value times 255. And then make it an integer. Set our color alpha m underscore sun, set color C. So that should fade the sun in. This one will be very similar. We'll fade out much faster. We're going to go from 1 to 0. Float value. Alpha equals alpha. Encode is fine, mostly. Okay. There we go. And we can even make that a bit more convenient, maybe. Fade in, fade out. Okay, so we should see the sun fade in. Oh, we didn't bring in the animations. So let's see here. So we need scheduler, animation action sequence. We might as well get math. I don't know if we need it. There we go. Gonna head out. Really nice progress to the game. Thanks. Eventually I'll do it myself again. Oh, I'm looking forward to it. Yeah. We've already talked a little bit about what you're gonna do. It sounds very ambitious. Or at least your dream game. Yep, you have a good evening. We'll see you around. See you tomorrow. We could maybe even move up another teeny little bit. Maybe. We can also clip a texture quad to a rectangle. And it fades out. And it does not fade in nicely. That's unfortunate. Okay. So let's write a couple of convenience methods then. We need this thing. Update float for a texture quad. Int alpha. Quad color. Quad set color. There we go. And now we just say update alpha. Update float. Good heavens. Okay. Update alpha of the address of our sun to alpha. Easy. Same thing down here. Now it's easy to add anything to this. Update alpha sun to 0. There's that pop. It renders once before the animation takes over, where it has opacity. So we want to, as soon as we say fade in, we actually set it to alpha 0. Then the animation takes over on the next frame. 875 maybe? That's another convenience method. This is very close to being reusable. Load planet. Image warehouse UV key UV. We're going to load a lot of planets, so we might as well make it convenient and simple and easy to work with. Texture quad and UV key. Set texture, set UV, set rectangle, set center. UV. UV. And then we scale everything, center it, good to go. So we're going to start by loading planet into our sun using image warehouse UV key sun. Make sure that works. We didn't break anything. Oh, that's true. Put all the arguments in. There we go. Okay, so there's our sun. Now we need all the planets. And not sure exactly what I'm going to do with that. So maybe we go to do a little bit of asteroid belt, outer planets. Okay, so here's what I'm looking at. Let me show what I'm. Oh, I can't. It's not convenient. Here we go. Come over here, share the browser. Like the first time I do this every day, nightmare. There's that. Okay, so we're looking at the size of all the things. Our sun is 128. And it would be nice if there was like a list of planets by size. We have Mercury, Venus, Earth, Mars are comparable in. Well, Mars is smaller. Known dwarf planets. Some of those I haven't heard of. They must be newer since the last time I looked at solar system things. Orbits. These follow Kepler's laws, which really is just ellipses. Distances and scales. Here we go. The radius of the sun. This is why we can't actually do anything to scale, but I would like to. I want a list of the planets. It's a good paper, but list of planets by radius. I just want a list. Is the AI really going to be the best? Oh, there we go. List of objects by size. Here we go. Okay, so there's the sun. Jupiter, Saturn, Uranus, Neptune, Earth, Venus, Mars. We're going to ignore moons for now. So if we call Jupiter and Saturn half the size of the sun, Uranus, Neptune. Earth, Venus. Oh, these are masses. I don't care about the masses. I just care about the radius. Moons. Orbital region. There's Mercury. Where's... I guess we only got 4. So basically we're going to do things by halves. That's mostly by halves. Jupiter is the biggest, so we'll give it a small bump. Maybe we'll go 625. Then Saturn at half. Uranus, Neptune at quarter. Earth at 1/8. Oof, that's going to be tiny. Earth and Venus. Okay, so I'm looking at this picture. We need to decide how big to make things. So if we go to our scratch buffer, we've got the sun at 128 pixels. Jupiter, Saturn, Uranus, Neptune. So these are very similar in size. Jupiter, if we go with 128 pixels and 0.625, that's 80, 64, Uranus and Neptune. Uranus and Neptune are just about half the size. That's really starting to run low on pixels for other planets, because then we have and we don't want exactly the sizes to match. Like there's no scale here, so we can decide what we want. So maybe we make this like 92, 80, 64, 64, Earth, somewhere between, so maybe like 48, Earth, Venus. Earth, Venus, Mars is smaller than those. Mars can be 32. Mars and Mercury aren't very featureful planets, especially not at these scales. So maybe this is a reasonable distribution of sizes. They're at least visibly different. Make it 24 pixels. Remembering that these are scaled by our scale factor, which is that. So these aren't actual values. This is basically what we draw them at. So the sun is 128, Jupiter's going to be 92. I think that's my plan. Okay. Where's Sleuth? GIMP. Back to GIMP. We have a sun. Now we need a Jupiter. Then we also need a picture of Jupiter to copy off of. We know we got the red dot. The biggest storm in the solar system. Oh, I've run out of alpha photos for today. That's too bad. I really should probably cut the carbs back out, but those alcoholics are going to go bad if I don't eat them. It's really more of a need, an obligation to not waste food here. So let's see here. We got 1920. Give ourselves a couple pixels. So 1918. 1918 minus, what did I say, 92 pixels? 1826. 1826. Set up our guides, then we don't have to work too hard. 26. 9246 from the bottom, whatever that is. And this thing is whatever. Okay. So we go to 2048 minus 92, 1956. That's 46, 2002. Okay, so Jupiter's going to fit in here. So let's go find a picture of Jupiter. They actually have like links, that would be handy. Jupiter. There we go. Oh, that's cute. See. Where's the big red storm? There it is. So they've got grays and browns. We just need something that looks vaguely like this, and we're going to exaggerate the color variation. So this will be very red, more red, brown, brown, narrow brown. Can we make it swirly? This is probably our image of Jupiter. We're going to try and imitate in GIMP. All right, Gimperoonie. Let's go back to GIMP. This circle. We did some math wrong somewhere. It's 92 is what I decided, right? 92. Jupiter. We'll truncate Jupiter. 92 by 92. That all looks fine. Good chunk. So there's our Jupiter. And then somewhere between 1826, 1918, somewhere in here. 1826 plus 46 is 1872. That should be our center. Mark off this area. And the red dot's going to be right about here. So we need a paintbrush. Grunge is fine. Reddish brown. And again, we're going to exaggerate this a little bit. Size 8, I don't know. That way. Kind of have swirl. Let's go with more brown. Maybe like an actual brown. Orange, I don't know. You know, like a whitish grayish actually. That's kind of a wide band. I'll go for a brownish color. Not as much red, more of a actual brown. And this is actually kind of interesting. It's got like these swirls, like it. Something like that. We just need a couple different browns. Let's go for like a darker brown to be the interface between the two regions. Maybe a lighter brown for some of these swirls. All right, then we get a narrow band of the grayish stuff. We get a real narrow band of the dark brown. We get more of the grayish stuff. It's not a very wide band. There needs to be a little bit more blending between the layers, I think. Then we need like a light mid brown. Oops, that did not happen the way it was supposed to. Come on. If I click the color, I want you to switch to that color. This is not rocket science here. Do some different browns. Go dark brown in here somewhere. Just for texture. So something in between this gray and this brown would be good. Maybe we can do a little bit of fuzzing along these boundaries here. Not a lot, just a little bit, just to add a little. Go to this red. I want it to be interfaced a little bit there. Okay, then it's one of those grayish ones. Although this one is a little bit more brownish, so I wonder if color like that, maybe. And that goes into our brown more. Or maybe go back to 8. Okay. Four. There we go. Just add a couple different browns in here just for blending things a little bit. I think I might need to just put a little more brown around the red here. Quite as stark red. Okay, let's get our darker brown. Alright, so we're gonna go with the mid-brown. We're not gonna have full opacity. We do want some of that reddish to come back through, so go back to 8 or so pixels. If only it would remember not to do that. Okay. I'm just gonna go with some brown. Okay. Does that look kind of like a Jupiter, maybe? Some of that reddish. That's not what I clicked on, thank you. Good gravy. Stop it. All right. There's Jupiter. We got a Jupiter. Next. One, 2 pixels over. Where are we at here? Anything? Jay Finelli, you're back. Doing the daily walkies. Yes, yes, gotta get the exercise. Can't neglect your health. You can't work on cool problems if you're falling apart. All right, so we got Jupiter done. Neptune, I think. Ooh, one thing we could do. Like an easy radial gradient thing. Let's see here. Bucket, gradient. We can go from white to black. Linear, I want radial. No repeat. Dithering, adaptive supersampling. Sure. If we click here, out to there, duplicate, delete, create the gradient. Instead of normal, this is a multiply. Kind of. Right, gradient. Goes from here to here. Yeah, we can make that. I think that's it. Good enough. Have to decide whether to merge that down. We can decide that later. Okay, Neptune. We decided Neptune was going to be, or Saturn. Saturn is 80 pixels. So from this point, minus 80 pixels, 1824. 1804 is 20. 94, 30, 40, 50, 60, 80. Okay. 1824 minus 80 is 1744. Right there. $2048 minus 80 is 1968. Right there. New layer, Neptune. Which we shall crop to an 80 by 80 pixel area. Whose center is at 1744 plus 40 is 1784. And then 2048 minus 40 is 2008. That should be the center for Neptune, so we need a picture of the Neptune. Blue. This one is much simpler. Blue and streaked. Some bits of white and darker patches like this. It's right here. It's probably about as good as it's going to get. So that's what we're going to aim for, something like that. Ellipse. Get our paintbrush, our grunge paintbrush. 8. I don't think we need much variation from that. We're going to go into the blues. And we're going to be fairly bright, because we can always dim it with the shadow piece later. We'll go with this. This is a lot. It's a lot less featureful. So I think if we do a blue fill, let's see here. Come across here. We do want it to look chalky, have a little bit of that transparency, like the person drawing couldn't be bothered to go all the way to the edges. Then we just go and get some darker blues. They don't have to be a lot darker. Then we can, oh, oops. 16. What this blue? We weren't going very opaque before. Now we'll get the darker one. there was, let's see here. There's like a darker blue band right through there. And one right about this height. About like so. Okay. Then there were some very lighter blues. 8. And fill in here and there. This dark blue, there's actually like an island, like a little vortex. Okay, then from the light blue, I don't really like these lighter ones that we're doing here. Make it more transparent, therefore more blended. What if we go black? What if we draw everything on black? Okay. There's Neptune. I'm not too upset with that. It's okay. It's fine. It's good enough. Okay, next up. Oh, but we are going to Neptune shadow, if I could type. Gradient. We go from here to here. Whoa. Foreground to background. There we go. And this is a multiply. And there we go. There we go. All right, Jupiter, Neptune. What's next in my list up here? Oh, that's... Shoot. Neptune should be 64. We skipped right over Saturn. Well, darn it. That's what happens when I get ahead of myself. Hey, Javest. Good afternoon. How are we today? I'm doing good. I'm doing good. How are you doing? We're drawing planets with chalk, sort of. Except we've already screwed up. 64. Neptune is not the next one in size. So we have to move our Neptune, I'm afraid. We need a Saturn. Oops. Whoa, 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 whoa. Okay, we're getting there. Doing good as well. Good. Just came home from having a drink with a friend. Good. Good. Got to get out and say hi to friends. Always good to visit with friends. So the next one in size is actually Saturn, which is this one. All right. So let's make a new layer group. Saturn. I'm going to make a new layer. And then crop it to the area we need. Duplicate Saturn's shadow. All right, we need to paint up a Saturn. So let's take a look at what Saturn looks like. If I go to the browser again, that's Neptune. We need Saturn. Saturn is at a crazy angle, if I remember right. Let's see. Isn't Saturn practically... Oh, they're gimbal locking me. Well, not gimbal locking me. They're preventing gimbal lock. Lame. But in this case, let's see here, Saturn, pretty sure it's rotated relative to everybody else. Where is... Mostly just brownish grays. It's actually not that interesting with planet. Slightly yellower in this one. Internal structure, atmosphere. What? They have clouds that are made out of hexagons. Pretty cool. So it is pretty tilted. Colombo gap, Maxwell gap. Dun, 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 dun. I thought one of the planets was like tilted 90 degrees. Which one was that? I'm getting too old to remember these things. Uranus did. Okay. So So I don't have to worry about that. Saturn can more or less be flat and be fine. Phew. Uranus, that's it. Yes, thank you, Robot J. I was like totally blanking. 98 degrees, that is a lot. That is very steep. But we're on Saturn. Browns, grays, yellows, and some rings. Okay. Here we go. This is kind of a brownish gray. We'll kind of be in this region, I think. We'll add the other stuff after. Let's see, go to this view. I don't know if there's even anything worth. There's that hexagon. I guess there's like one dark stripe here. More brownish than a lighter. Okay, well, we can just get started, I think. So here's our Saturn workspace. Paintbrush. We can start off kind of big, just rough in a couple of colors. Nope, not like that. Opacity, there we go. Okay. Couple different browns. Maybe we'll go with more of a gray. They did have one that's more yellowish, layer or two. So maybe that go in there. Okay. That's a little bit not the brown we were looking for. There's really not any big features. So the trick with Saturn is it needs to be wider. Oh, we can get one of that more yellowy one. 8 pixels. It's not a very featureful planet either. We'll give it a little bit of okay. Put in Saturn's case. We want some room for our rings. We need to draw some rings. So our width will be 160. Oops. 160 centered. There we go. Yep, Saturn's going to be just wide. Okay. How's it going, Robot J? Haven't seen you in the chat for a little while. Saturn's rings. We need to distinguish Saturn's rings from Saturn itself a bit. This is the new Saturn edge. From here, minus 40, 1704, 64. We get an ellipse from, oops, about there. We're gonna have to do something with these colors so that it looks different. Maybe just more gray. Paintbrush. Okay, make another ring. Different color, maybe more of that. All right, let's erase the rings from the front of Saturn. I'll even cheat just a little bit. Putting that little pixel of black border should help quite a bit. Then on Saturn itself, we'll add a little bit of a shadow. We'll just go with black. Opacity pretty low. That's just going to be under the ring here. Maybe a little more opacity. And the shadow has to be over Saturn itself. There we go. That distinguishes the rings a little bit better. Okay, Saturn's shadow. Gradient. From here to here, using foreground to background, flip-flop white, multiply, and then Saturn? Is that a believable Saturn? Believable enough? I think it's not too shabby. Okay. Let's see. Next, Saturn. So Uranus is the one that's rotated. So we need to move Neptune again. Neptune keeps getting kicked down the road. Uranus also, I believe, has a ring. And we were going to make Uranus 64 pixels. So the same size as this guy. All right, so let's give ourselves a 2-pixel buffer. 1, 2, because the GPU interpolation can go outside of the actual UV coordinates a little bit. So you don't want to be like pixel on pixel adjacent. So that's 662 minus 64 puts me at 1598. That's 64. Then 2048 minus 64 is some number. 2048 minus 64 is 1984. 1984. 2016 is our midpoint. There it is. Okay, Neptune. Oops. 1, 2. Remove Neptune over. Oh. Neptune group. Need to move the whole group at once. There we go. Okay, Neptune. So we need Uranus. Fun times. And they are the same size, so that's good. These will get easier and easier the smaller we get. Okay, so I need a picture of Uranus. Let's go take a look. Well, that's not terribly inspiring, actually. It's just kind of in true color captured by Voyager 2. Pale muted appearances due to the shroud of haze above its cloud. It's just not that interesting. But it is at a 90-something degree angle, right? 98, 97, somebody said. Jay said, argument of perihelion. Axial tilt, there we go. Does it have any rings? Rings. There are rings, but they're very faint. Seasonal variation. Yeah, there's just really not much of a ring here. We're going to draw it at basically 90, maybe slightly off. Yeah, it's like a pale blue-green. So that's what we'll go with. All right. New layer group. Uranus group. 1662 minus 32 is 1630. There's center. Is it worth doing the ring for Uranus? We might still. All right, I'm going to crop this bad boy to the right shape. Duplicate. We need the shadow layer. These things look flat if we don't put a little shadow around them. Okay, Uranus. Paintbrush. Big size. Oh, I want like a maybe a little more blue. Something like that. And this bad boy is laid out top to bottom. About like that. We'll go with a more blue. What are we doing? Oops. I'm gonna go back to this one with full opacity. I can't believe we weren't full opacity with that one. Then we'll go with this one. And we'll just fill in some of these areas for variety. We don't want our thing to look flat. There's Uranus. Do I want to put the rings in? They're thin, they're white, there's like 3 of them. Rings. Extremely dark particles. 13, that's too many. There are rings though, so maybe we do have the rings. All right, new layer. Uranus rings. Layer boundary size. We're gonna make it. Oh, oops. Crop. Okay, well, we got these backwards. We entered all of our data into the shadow layer. So just swap them. Rings. We'll make it twice as high, 128. Center it. There. All right, we need an ellipse. And it's going to be basically white. And very, very thin. Where's our paintbrush? Like 3 pixels. Ellipse. Stroke. Teeny tiny thing, edit. Stroke. Is that it? Ooh. I've got mail, thanks, son. Oh, never like seeing those ones. Okay, that's what I have to deal with right away. All right, reading. So I have to erase what's behind. So I'm going to go with this side. Eraser, give me a circle. Why does it keep doing that? I really hate when it does that. There it is. Okay. Okay. So I'm going to erase the rings over here. Uh-oh. Oh. There we go. Okay. And on Uranus itself, paintbrush, back to our grunge. This will be very small. Black and not as opaque. We kind of want something shadow-like. I want a little bit. Ooh, not there. A little something here. First of all, that's not what I said. Okay. All right. Now we need to put in the shadow, which we've done a couple times now. I don't know why this cannot foreground to background. White to black. From here to there. Multiply. Move our control point. Give us a bit of alpha. The rings. Good enough. Okay. All right. Robot J. Yes, yes, yes. Okay. What else we got? We got more planets. We got more planets. Neptune, we did. Earth. 48 pixels. That's all we get. So let's go find a decent picture of Earth. I live in the United States, so we'll probably try to get. Feel like I don't have good control of this rotation. Whoops. Oh, come on, web. Okay, there we go. All right, well, we'll try. No guarantees. But it's the one I live on, so we'll spend a little bit of time with it. And Earth will be 48 pixels. So 1, 2. And this line is at 1530. 1530 minus 48. 1530 minus 48, 1482. So 1480 minus 48, 1434. Just getting ahead of ourselves for 1430 for Venus here. 1, 2. be 8. So we should just be able to go down to 2000 and 2024. Earth and Venus. So 1482 plus some number 48. 1482 that's 24. 1506. 1434 plus 24 is 1410. Plus 24. 1458. There we go. Okay, so Earth and Venus ready to go. Earth, Venus, Mars, Mercury. All right, we're gonna pause here for just a moment. So I think it's about time for a restroom break. All right, we'll be back in just a minute. We'll continue on making the planets. Okay. Earth and Venus. So let's take a look. Earth, oh, we've already taken a look. Aim for something like that. Okay. Venus group. Let's see. Mercury group. We'll go down to all those in a minute. New layer. Earth. Crop. Duplicate. Shadow. Venus. Venus's shadow. Oh, let's see here. Venus, what's wrong with your size? Your size is fine. It's my guides that are wrong. So all we do is 1, 2. Move the Venus group. There we go. Make sure things are looking okay still. All right, Earth. Paintbrush. Grunge. Got to 16 pixels. We want greens and blues, so green. We want to constrain our drawing to the circle. Okay, so you kind of have a oops, too many undos. I'm gonna put some white in up here eventually. It's gonna come down. Back out into South America or something like it. Then Europe can kind of be poking out over here. Baja California, a little more Florida. We do want white. Oops. All right, let me go back up to 8 or so. I kind of want to color in the blues. Behind the current Earth. Then maybe a little bit on top here. Maybe some darker greens. Where's that green? Just along the edges. South America. I don't know if that's identifiable Earth. That doesn't look very good to me. New doodad today. Yep, we're trying to do the Earth here. Not too happy with it just yet. Not sure it really looks very much like North and South America here. Yet. Another thing is that the southwestern United States is a bit on the tan side, tannish brownish. So maybe that would be helpful. Into Mexico, let's see. Yeah, it's not great. What other planets I can kind of get away with as long as I follow the general pattern. This, I don't know. Back to this pale one. I clicked on the color. I expect you to set the color. Thank you, GIMP. Let's see. What am I missing here? All right, let's add a shadow to it. Gradient. I'm gonna go foreground to background. Here to here. Multiply. Some of the Earth's oceans just need some more blue. Maybe a darker blue. That's too different of a blue. Yeah, that might be identifiable enough as Earth. going to be a little small on the screen compared to the other stuff, so maybe it's fine. Okay. Yep, the doodad today is going to be space on the chalkboard. We're going to put the planets up there, have them rotating around, that kind of thing. Maybe do some other things. We might spend a day or two on it. This is, you can do a lot of different things with space. Do some stars and some nebula, that kind of thing. All right, Venus. So let's go take a look at what Venus looks like. Well, there you have it. That's a Venus. Let's see what else Venus can look like here. Any other pictures? See, super not helpful. Some of these pictures. Cloud structure of the Venusian atmosphere made visible through ultraviolet imaging. True color image of Venus. See, that doesn't help much. The cloud layer permanently obscures the surface. We're going to have to fake our own cloud layer. I think that's the answer. All right, GIMP. Here we go. Once more into the breach. We're going to move our centerline guide 2 pixels. We're going to select our drawing area. I'm going to go with more yellows, I think. More like yellows and whites. Try to make things look wispy. Size 16. Okay, then we're going to go for something more pale. Then we'll go for something in between. And not very opaque. Let's try to smooth out. Make it look a little more like cloudy. Extend some of these narrow bands maybe. Sure, that could be a Venus. I can believe it. Gradient white to dark. Foreground to background. Center to here. Multiply. There's our Venus, I guess. 1, 2, 3, 1, 2, 3, 4, 5, 6. We need a Mars and a Mercury. Don't be done drawing for a little while. think Uranus is a little bit dark. Has too many dark blue streaks. So let me come back through and tidy that up a little bit. Make it a little bit paler green blue. All right, Venus, Earth, good to go. Mercury, or Mars, 32. 32 pixels. So if this is our edge, 1430, back to 14, and 2 more. One, two. Then we want to be 2048 minus 32. Gives me at 16. So there, I think that's Mars. Okay, Mars will be red and kind of splotchy. Yeah, we're not doing things to scale, but they are indicative of scale, I guess. Saturn's not that much smaller than Jupiter. Then Neptune and Uranus are pretty close together. Earth and Venus pretty close together. Mars and then Mercury. So hopefully this is good enough. New layer, Mars. Edit the size. Duplicate. Here's where we'll get our shadow from. Okay. Paintbrush. Small, and we want like that brick red. And we undid too many times. There we go. Paintbrush. Mars is more splotchy, I think, than the outer gaseous planets or the cloud-covered ones. We should look at a picture. It's probably more orange than I'm giving it. Come over here. Mars. Yeah, we got more splotching, red, reddish, brownish, rusty. Mars. Yeah, it's more orange, really. So this color is not. Um, okay. It's not really striped though. It's more splotched. So if you get like a rusty brown. Doesn't need to be darker. We want like a spackle, a splotch, smoke. That's huge. Bristles. Hmm. I'm gonna say that's probably good enough. Mars gets a shadow. All right, multiply. Okay, Mercury. Mercury's next. Mercury's not very big. We're just gonna go with basically gray, scarred, scratched up. Where's Mercury? Yep. Just a splotchy gray mess. Okay. That's something you can do. And we've decided Mercury is 24 pixels. That's not very big. Does not give us a lot of room to play with here. So from here, 1396, 84, 84 minus 12 is 72. 2048. $2024, and that in the middle. Okay. New layer group. Mercury. Okay, duplicate. So we have a place to put our shadow. Paintbrush. Back to grunge. Size of 8. And we're just taking gray. Okay. Undid my selection. There we go. Paintbrush. Is that it? I mean, basically, right? So we have tons of detail here. Okay, shadow. Custom radial, etc. Okay, come up to here. Multiply. I might not do a shadow on this one. Maybe I'll do my own shadow around this one. It's just so small. Okay. Is that it? Is that all of them? So many guides. Okay. We have a lot of like midlines for things and such, so. Very cluttered though. Okay. So we're going to export our image. When it comes time to export the UVs, I have to make some choices. I think we're going to choose to merge down these shadows and the rings. Uh-oh. The shadow merge down first, then the rings. Okay. Shadow first, then the rings. So this is Earth's green over the blue, then the shadow. Merge down, merge down, merge down. Okay. In theory, all of these should be ready to use. Might as well simplify our file a bit. Delete, delete, delete. Okay. Let's just do one called planets. That's not quite accurate, but whatever. Because we do have a sun in there. Okay, save. Export. Now we're going to export the UVs. Okay. That's it for GIMP for now. That was quite a bit. That's enough to get us rolling. We have our sizes locked in. We have a sun. We're going to go Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. All right. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Initialize these. Okay, Sun, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. Phew. Okay, there's that. Paid and update alpha. Let's see, we're gonna do the following. We're gonna line these up. There we go. All right, we're gonna initialize everything to the correct alpha. Okay. We're gonna do the same thing with here. Except 0.0 becomes the alpha value we're passing in. These floats are being truncated to integers anyways, no reason to mess with that. We'll do the same thing here. That should do it. They'll all show up somewhere. Update doesn't do anything yet. Render. Render. Render set bounds. All right. I know not all the orbits are coplanar, but we're going to start with that. And we're not going to move anything, obviously, for a little while. Get that all hammered out. Okay, okay. I'm going to start at the same Y. Just going to do some boilerplate so we can add custom offsets in a minute. Okay. All right, so Mercury. I'm gonna subtract for now. Let me just gotta get them all on the screen. That's the important thing. And we're gonna move $100 pixels off. 120. I mean, let's just make up numbers, right? We can. This is not where they're going to be anyways. We just want to get them all on the screen. Jupiter needs to move quite a bit more. Let's go like 40, 6, 280, I don't know, 320, 360. I don't even think our board is that wide. Okay. All right. So we need to embed our new image data. Oh, wait. Lift that up. Yeah, I need to export the UVs real quick. I thought we did that. There we go. Let me embed our data. Okay. Space, compile, tidy up, and debug. Fun. Okay. Eight planets. I don't know if we're going to do asteroids. We could. I mean, you got your series and a bunch of little teeny tiny ones. But I don't know. I don't know if we're going to do that. Everything is scaled by 87.5% down. But I honestly don't know if we have enough room on the chalkboard for this. Let's see here. One question we might have is the solar system orbits all at once. Are they all? I guess I've never looked that closely at it. Solar system orbits. Does this do like a time lapse of all the orbits? It has inner and outer. Outer planets. Yeah, I'm not seeing it. Ooh. Okay, that's an easy fix. All right, let's just see if some things show up. Well, our chalkboard faded away, so that's awkward. Most of the planets didn't work very well. Well, well, well. That is awkward. I mean, memory is overlapped because we didn't do something right. Hmm. Texture quad. Clip? Oh, I don't have clipping for texture quad. I have clipping for text quad batch. I don't? Seems odd. I could throw in a clipping. Oh. Okay. I thought we still have these lines coming for now. That would explain why the build is not working the way it's supposed to. Text we have clipping. Set clipping enabled. Clipping rectangle. Okay. I had something else somewhere that was clipping. Clipping. I thought it was one of the texture quad ones. Is it color quads? Set clipping entity. That's it right there. So I guess we need that for texture quad. If we can't keep all the planets on the board all the time. Okay. Well, so where did my chalkboard go? And all of my planets. Um, I'm avoiding debugging here for a second. Basically, we're looking through to see if the thing was already loaded into our list of objects. If not, we look for the first null, and then we shove our quad into that area. Chalk space dot load planet. Could not add space object. Okay, so load the planet. Fade in. Int index equals 0, index less than num objects. So we're gonna be using this list for important reasons later. So while I think about what's going on with this thing. I just do a full clean debug. I don't like doing it, but we'll do it. Did I not? I thought about it. Okay. The next thing up we have is something that looks sort of like elliptical movement, which means we need parametric ellipse. T. And we can add an offset. Okay, we'll come back around to that. This is going to take a minute. So basically, in our update, x equals some offset to the sun, right? So sun.x plus some radius times cosine of our parameter t, and y are 2 times sine of our parameter t, and our t has to update given some scaling factor for the planet, so that the inner ones go faster and the outer ones go slower. That's the heart of what we need to do. The other thing we need we'll see how that goes. This takes a minute. Okay. Sound embedding takes a while. Yeah, we might spend 2 days on the solar system. We spent a week on the Archer. So every planet needs an X, Y, a Z, a period, the X, Y of the center, which is the sun, but then it needs the 2 radii. And I think what we kind of want is the outermost extremes. They'll probably figure Neptune and Mercury out, their periods and their numbers, so that everything stays on screen more or less. Then we'll film the rest of the planets with values in between the extremes. And I don't mind if Neptune takes a full minute to go around, which means everything inside of that is going to have to scale, so Mercury is going to be going around pretty quick. And we're not going to do it to scale, but they'll be indicative. So no inner planet is going to go slower than an outer planet. Yes. Yeah, I got some strange behavior for the fading things to alpha. I don't have any reason that I can think of why it would behave the way it is. Whether I haven't thought about it enough or it's just a weird build artifact that a clean will fix. Oh, Sound Warehouse. Turns out there's an awful lot of sound data in the music. Oof. Oh, I love taxes. Ugh. Gotta pay them though. Otherwise they get you in trouble. Oh, good. Sound just finished. There we go. We're into the executable finally. Okay. Now magically everything will work better, right? Right? Well, that was not according to plan. Why is my chalkboard fading in and out? I'm not... What is going on with this thing? Space. Doodad chalk space. Doodad chalk space render. Chalkboard first, then the doodads, then everything else. Chalk space, give it the old... Fade in, fade out. Okay, objects initialized to null. Every time we load a planet, we find an open slot in our objects and throw it in there. When we fade in, we update the alpha for every object to 0. And we start an animation 0 to 1, float value, value times whatever. Update alpha. This was working with the sun. The sun was fading in and out. Fade out. Animation go from full alpha to no alpha. For the animation, then set ourselves to disabled. If we're enabled, we do things. I know what's going on. Glad we came and looked at this. Saturn. Saturn is the problem. We need to scale Saturn to just the content. That's why things are fading weirdly and doing odd things. Okay. So that means we must go to GIMP. We're going to find Saturn. Saturn takes up the whole image. So layer, crop to content, then boundary size. Width was 160. And there it is. All right. Now we export UVs. We were so close. All right. One small error, but the behaviors are just odd. Okay, UVs. Saturn looks more normal now. Images.text. I'm glad we looked at this. That was an easy one to spot once you looked in the right place. Way better PNGs. Make sure that's good. Okay, we're going to rebuild our image data, and then we should be good to go. Always something. One little step you miss. Image time, need to make this into a pipeline. So that you just kind of kick off processes and it automatically does all the right things or something like that. Okay. Image warehouse takes a minute. Not as long as the sound warehouse. And the sound warehouse is only going to get worse. The image warehouse probably is about as big as it's going to get. I have nothing we want to add that we probably can't fit inside of another texture we've already got somewhere. Okay. We can also start with a phase. Phase offset, so all the planets don't start at the same point in their elliptical path. You'll see why we put these all on a list here shortly. Probably. Okay. Hey, there's a bunch of planets. Yeah, this is going to be kind of hard to actually fit all in the space given. And I'm kind of okay with that. Yeah, not bad. Not bad. Okay, cool. Reify. That's a word I don't get to use very often. All right, journal. Draw some planets chalk style. Notes. Sun and planets have been drawn and display in the on the chalkboard. Okay. Dum dum dum. Parametric ellipse from 2 points from a single point, maybe. Let's just start with a parametric ellipse. Big depth. Improve ellipse with offset. Okay. Let's see our work here. I don't want to lose this work. Add, so let's see here. Image work. Game context, add the new thing. The game scene has the new thing. The image warehouse make file. Okay. Add everything. It's not even 4 o'clock and we're starting to move into making things move again. Planet, let's see here. Space doodad shows sun and planets. There we go. Okay. So we're gonna add elliptical, improve ellipse. Offset, let's see here. XY offset, period, and phase offset. Good enough. Okay. All right, space. Yeah, I don't know if we're ever gonna get an asteroid belt. There's probably not enough. I'd probably overclutter things. Okay, update. T. If our period is in seconds, it would take T plus delta T in real time. Real delta time. Delta real time. A period and 2 radii. For each planet. So here where we have the objects, maybe that's not the best thing to call it. We need a struct. Need to think about how I want to store this data. Maybe I'm overthinking it. Maybe we just need to do this. Struct orbit, which has a float period in seconds. T, which is the current T, time, float x radius, y radius. Then we need orbit. Extra quad star underscore quad. Orbit, orbit, body. Just call it a body. While we're here, we might as well do x, set, y offset. Then everything we need to render out to the ellipse over time. Period, radius, radius. All right, we initialize every body. Then when we load a planet, it's a little bit different now. Load planet. Dot quad. Dot quad. Okay. Render. Load planet. Okay, now our update loop is going to go through each space object. Body. Body is not equal to null pointer, or if body quad is not equal to null, and body point to period is greater than 0, then we do things. We will call update body. Okay. Delta time. So pass it in. Float dt. Okay. Body point to time plus equals dt if body time is greater than body period, then body time equals f mod body time body period. So P equals body time over body period. And then T actually needs to be multiplied by 2 pi, which is in math. So we do have it. 2 times math pi times our time divided by our period. So that's one full loop-de-loop around. We compute our x and our y, given our body point to x radius, body y radius. Sun X, Sun Y. I'm fine with that. Then we take body point 2 quad. Move to X, Y. Okay, now, initially, nothing is going to rotate because we haven't set a period for a single planet. We're just checking the compiler errors, basically. M objects, blah, blah, blah. Not quad. Yep, I agree with that. Rectangle.x, rectangle.y. Okay. So nothing should move from where we initially placed it. And it crashes. Possibly I know why. We don't need new image data, so we did change the shape of our memory. A couple of simple ellipses could be fun. Hoping definition as a locus of points. Cartesian coordinates parameterized. Standard parametric. Okay. We'll just see how we're doing here. $4 o'clock. Okay, nothing's moving. That's great, just like we predicted. And we're going to add Mercury. Oh boy. Ugh. Load planet Mercury. What we want are the 2 radii and a period. That's really all we want. Load planet. Period. Float x rad. Float y rad. Okay. Period. Now passed in. X radius. Y radius. Okay. Sun 0, 0, 0. We're just gonna do this, I think. Get started. Okay, Mercury. Our period will be 5 seconds to start with. Why not? Our X radius is going to be the width of the sun is 128, so let's go out to like 136. If we make Neptune take a minute, then our X radius will be not very tall, maybe like 16 pixels. I don't really know how sure that's going to take up. I'm just going to fiddle just a little bit. Compile. Try it out. So Mercury should kind of zing along in front of the sun. Oh my goodness. It's kind of working. Well, that's a radius, so that's actually out further than I expected. Nice. Oh, I've seen worse. Okay, well, we'll get rid of that. If I want to add an eccentricity, like not center everything, is there a way to do that? Using our parametric, what's it? A cosine T, B cosine T, if we're centered, but I want the focus general ellipse. Implicit representations, polar forms, eccentricity, and directrix property. Maybe I'm overthinking it. No, maybe not. That's parametric representation, standard parametric representation. Yeah, it's always about the center. Eccentric anomaly in astronomy is not the angle with the x-axis, has a geometric meaning, blah, 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 rational representation. So I think this is probably good enough. Nobody's going to fact check me on orbital mechanics on a chalk drawing on a board, right? Right? Let's not overthink it. Let's just get it close to right. So our X radius was big. 128 would be 64. So let's make it like 68. maybe not 16, maybe like 8 pixels. Neptune, the furthest out, we're going to put a long ways out. I don't know what that means. Maybe like, hold on. Move to Neptune 360. Let's simplify this so I can read it easier. Why? Okay. So 360 make this out 30-ish pixels? I don't know. So we're going to make 2 planets crank around in elliptical fashion. All right, Neptune. Okay, Neptune's not working the great, but Mercury is actually about where I want him. So we might have some cleanup artwork to do, but we're not worried about that just yet. Okay, Neptune. The period was 360. That's not right. That's not right. Okay, Neptune should have a period, and we're gonna make this fast for the beginning. When this is 360. We'll come back around and make Neptune like a 1 minute, but we're gonna whip it around pretty quick. 360 and 30. I know that there are some orbits that are more tilted than others. I don't know if I want to do that. We might do that. Unclear. Okay, so there's Neptune. Going around the sun or something like it. Okay, so we can actually go out a little further and up and down a little further. Just a little bit. We're setting our extremes here. So maybe like 380 and maybe 35. And all of these will have to be scaled, but we can do that in the other thing. Shockingly, not the worst beginning for elliptical rendering, or path rendering here. Imperative, okay. What if we select letters, LMNTS? Ooh, it just misses the T. Perfect. Maybe we move everything down just a tiny bit more. But overall, that ain't half bad. Okay, let's just add a bunch more then. 10, 9, 8, 7, 6, 5, 4, 3, 380, 35. So we'll go 30, 25, 20, 15, 10. These are obviously not the correct values. Actually, let's do this a little bit different. Let's go 31. We'll go down by 4s. 27, 23, 19, 15, 11, 7. And this guy go around every 5 seconds. Let's go 5, 6, 7, 9, 11, 13, 15, 17, 19. These are not the final values, obviously. 68 I was happy with, 380 I'm happy with. So let's go 3. Let's see here, Uranus, Saturn. These inner planets can be quite a bit closer than the outer planets. 80. Let's just make up some values. We'll see which ones look wrong and just touch those up. So 90 would be a 20 pixel variation. 120. We're going 30. We had 40, 160. We had 50, 210. 210 plus 60 might be 270. 270 plus 70 plus another 40. Yeah, so this is going to be a little bit crunched between Uranus and Neptune. We're just getting things loaded up. That's all that matters. Just getting started. It's only 4 o'clock, so this is going to basically have planetary motion done today, I think, including render order problems that we're going to run into. Okay, so if we select some letters, Saturn. Some issues around several of these things, but so some of the visuals need to be cleaned up. But not too shabby, really. I think maybe we just put black. We have too much alpha showing through for chalk drawings on chalk drawings. So you can see Uranus clips the bottom. We're gonna have to fix that. Nothing else does. We also don't want anything to go any higher than that. So maybe we drop everything down a little bit lower and have more things clip off the bottom of the chalkboard. So we're gonna have to do clipping for text quads, which would be GLSL work for us. And yeah, we have order issues, which we have not addressed yet. So kind of cool. We're getting there. One step at a time. Okay, so in our journal, parametric ellipse done. Planets move around sun in ellipses. Texture quad flipping. Planets move around sun in ellipse. That's the thing we're going to have to do. Improve the ellipse XY offset, no, but a phase offset and the period actually is already working because we already had it in there. The XY offset is not a thing that we need. Fake our depth. Faking depth might be easier than I'm originally thinking. Out of hot water. Okay. So if we go to set bounds, this y value, we just want to move it down a little bit. So 6, 2, 5 we tried. So maybe go to 6. 5? Where are we at? 8, 7, 5. We had 6, 2, so maybe go 6, 4. Somewhere around there. We want more things clipping off the front. These things load planet. Renderer scale. That's going to be important. Period does not need to change. Okay. Texture quad clipping. Faking our depth. We'll get to that shortly. Improve the ellipse with a phase offset. That's not. Start with phase offsets. Asteroids question mark. I do want to do stars and nebula. Maybe we won't get to nebula today. I don't know if we want to do asteroids. Let's just make sure we didn't break anything. Save our work, and then we'll work on the next task. And I need to heat up more water. I'm out of water. I also need to close the window. It's finally getting cold enough in here. Okay. Okay, so I didn't break anything. Nothing else clips off the bottom. That's interesting. It's fine if those rings cross, I think. None of the other planets should be interfering with those letters any. The rings of Uranus, fine. That's fine. Okay. So we want to clip, add clipping to texture quads. So all planets moving around sun now. Movement still to come. Okay. Well, I'm going to heat up some water. And then we'll make things look better. So when I get back. All right. Be back in a minute. Okay, JTL, heading off for the night. Have a good one. You too. You take care, and I'll see you tomorrow. All right, what are we doing? What are we doing? We are texture quad clipping. Okay, so this is shader work to start with. We have the color quad vertex shader. Clipping enabled, clipping rectangle, viewport clipping MVP. And that's going to go into texture quad vertex. Right there. Anything about clipping? Viewport screen space position. Oh, we just need this whole function before our main. GL position, color, if clipping enabled, we do some things. Then color quad, fragment shader, sign, test point in triangle, test point in quad, into texture fragment shader, texture quad fragment shader. Clipping enabled. Fragment coordinate is given to us automatically. We don't need the color. All right. So what we're doing is taking that vertex buffer and we're computing screen coordinates. Then we're handing in those corners to the fragment shader, and then the fragment shader decides this thing. If clipping is enabled, basically this, right? Test point in quad. If inside, then we do this. Is that it? All right. Tools bin, embed, shaders.exe. Okay. We could test our shader. Probably should do that. Let's see here. What's it called? Shader Playground? Is that what I was using before? Okay. So here's our shader playground. We're going to put in GLSL. This is a vertex shader. Target Open GL, whatever. Paste. You have to wait a minute. And as long as it outputs something meaningful here, it means we aren't that far off. Target OpenGL. Yeah, looks good. Oh, there we go. What? 3 compilation errors. VP0 not declared. World to screen. Hey, hey, hey. I put, oh, come on. That's not what I said to do. There we go. We have to wonder why. OBS is fighting me. Come on, OBS. Stop sharing the browser. Okay. All right. World to screen. VP0. Used. Oh, come on, we worked our way through all this before. And this. Better if I only share the browser on the same screen. Right, so it's in theory compiling something. We've declared this X as an output. We transform the 4 corners of our clipping rectangle. 1 extraneous semicolon. Where's an extraneous semicolon? Where did I put an extra semicolon? 25. There. Aha. Okay, so in theory, oh, doggone it. That's when I change windows, I lose my mouse. OBS and my browser fight over the mouse. And then I have to stop sharing the browser to get my mouse back. Sheesh. Okay, so in theory, shader playground should tell me that I'm okay. If it ever finishes. Hey, it outputted something. Okay, now next. I'm gonna go to share the browser, just so you can see. So it output actual Spear V op stuff. Paste our fragment shader in. So this has those points as inputs. Where is frag? Vert. Geom frag. Now we wait for this to compile. So basically, we had these 4 points and in screen space, and we say test if the point is in our triangle. Location qualifier on output not supported for this version. Line 3. Oh, that snuck through. Yeah, I thought I'd removed all those. I think we do that. Okay. So in theory, oh, good gravy. Now I've got to turn off the browser again. No indication where my mouse actually is, so that's no good. Okay, browser back up. Okay, so in theory, all I have to do is that, and we'll recompile, and maybe it'll be correct. Not sure why it's saying GLSL 4.5 when I've stated I only allow 330. Not clear to me. Hey, it worked. So we have no issues there. So both of our fragment shaders and our vertex shader should be okay now. Let's embed those. Now, color quad, set clipping entity is a thing that texture quad might need. Where am I storing that? color quad. Clipping entity. Everything to do with clipping. Should be color. Okay. If we're clipping, we do a bunch of stuff. Otherwise, okay, that makes sense. Or we do our draw. Find things, texture things, binding, etc., etc. And we test if clipping We're a different shader, and then we need the probably this. So let's actually go take a look at our shader warehouse. These ones. Here, clipping enabled, rectangle MVP enabled. That should make no difference to our actual execution yet. I just want to make sure that we didn't break anything else. Almost 5 o'clock. Okay, we got references to color quad. We've made some copy paste things here. There we go. That should fix most of those. Clipping, oops. Okay. Just because this build succeeds does not mean anything, because shaders don't get exercised until you actually run them. Okay. So it's not clipping, that's fine because we didn't turn it on. Okay. Base. All right, when we do this, set bounds. This move 2 kind of doesn't matter because the first frame moves it somewhere else. So actually, we can just put it somewhere nearby. It doesn't matter. Okay. You know what? Quad is not equal to null. There we go. Okay. Let me set bounds. We're going to do that. And another thing we need to do is set clipping entity to this thing. So this is the blackboard thing. It's going to have these boundaries here. And that basically does it, I think. In theory. Time for bed. You have a good night, sleep, and we'll see you tomorrow. Undefined reference. Text quad. Okay, I know what that means. Underscore clipping it equals entity. No. Shader is invalid. Okay, all right. I get the point. Get the point. Viewport. And I think I know why. Texture viewport. Texture quad. Texture clipping enabled. Clipping rectangle. Clipping MVP. Enabled rect MVP. We still have color quad. Why do we still have color quad? See that? Shame. Texture viewport. We were so close. Just a little GLSL for the day. Mostly copy paste, which is fine. Okay, try this one more time. Let's see if we can get that clipping to run. Hey, it's clipping. Beautiful. Just beautiful. Okay, we have too much alpha for some of these planets. We're going to have to go back and tidy up the art, but that's not really an interesting piece right now. Okay, so that piece is done. Journal. Texture quads now clip and Uranus rings put at edge of blackboard. Making our depth. Start with phase offset. That's probably an easier task. In fact, it's so easy. I don't even think we need to do this. We're going to load planet. 0.2 time equals math URNG, which means uniform RNG, we need it here. Next, float up to period. And that's it. We just start not at 0. Then everything doesn't start over on that edge, it starts wherever and goes. There we go. Yippee. Okay, so those were 2 easy things. Take the depth. Texture quad now clips. Planets clip on edge of chalkboard. Good enough. Okay, we need to fake some depth. Okay, depth has 9 things in it. fake our depth. You're ready? We're gonna fake it. That's how we do. These are structs, and therefore an assignment copies all the fields, including the pointer, which is what we want. So I don't think this is that bad. Here's what we're going to do. Sort bodies. All right. Bool has changed equals true. While we have changed things, clear a flag equals false. And then a double loop. This one. Next one. Index 1. Then we need index 2, which goes from index 1 plus 1 to our number of objects. This will be index 2. You get body 1 equals bodies. Okay, that's the next one. We'll get body 2. That's index 2. And for now, we're going to sort based on Y. There's one special case we have. That'll be fine. So if body 1 dot quad rectangle dot Y is greater than, we want to move body 1 later in the list as long as it's greater than other elements. So this is, we're doing a bubble sort, and technically it's blah blah blah, terrible, whatever. But it turns out in this case, from frame to frame, there will be almost never any actual changes. And so essentially, most frames, we blaze through once and we're done. And then every so often, there'll be 2 that swap. it's going to be very rare that this needs to be anything faster than a bubble sort, because bubble sort is very, very, very fast. If you have very small sort sets, and if it's mostly sorted most of the time. In this case, this is like the optimal place for a bubble sort. If I used a quick sort here, it would be slower than the bubble sort every time because of the nature of our problem. Is less than body 2 quad, I think, y. Then we swap. Equals the contents of body 1. The contents of body 1 equals the contents of body 2. The contents of body 2 equals temp. Has changed equals true because we swapped something. Is that it? Probably fine. We could count number of swaps. We could count number of comparisons. Those are all valuable things to count. But for now, we just want it to work. Bodies. Objects. Oops. Okay. Easy enough. And like I said, there's one object that we're going to consider special eventually, but not yet. And it will have a different update cycle, and it will have a fake depth value. Okay, well, things are still not going behind the sun because we haven't actually called that method. Oops. I know I thought about it. Here, after the update, but before the render. So we go through here, we update the bodies, then we sort bodies. So we update all the body positions, then we sort them once, then the renderer takes over. Hey, things are going behind the sun and in front of the sun. Outer planets are over the inner planets. Earth is in front of Venus. Hey, we got our fake depth. Not bad. That was pretty easy. Now, let me show you why bubble sort is going to be so efficient here. If I come over to space and I say uint 64t m underscore max compares max swaps total compares total swaps. We're going to print that out in the destructor. So in our constructor, we're going to just boop, Set those to 0. This is going to be so much less than logarithmic. Whether we measure comparisons or swaps, either one. We also want to frame count. Frames active. We'll delete all these later. So in update. If we're enabled, frames active gets incremented. In sort bodies, for every comparison, m underscore, let's just do this, swap count, compare count. Here, our compare count gets incremented. And here, our swap count gets incremented. When we're done, we're going to say compare count is greater than m underscore max compares. Max compares equals compare count if our swap count is greater than m underscore max swaps. Max swaps equals swap count. Okay. So every frame, we count the frame, we count how many times we compare, how many times we swap, and we just keep track of what's the maximum, and then m underscore total swaps plus equals the swap count from this frame, and the total compares plus equals our compare count from this frame. Then in our destructor, we can print that out. Doodad chalk space dot destruct for okay. Total compares 1.0 times the total number of compares divided by m underscore frames that we spent active. Total swaps. We might as well print out our frames active. Just for reference, right? Frames, modulus ULO. Where's it LLU? I never remembered. Max compare. Max swaps. Average swaps. Average compares. Get your cursor backwards. Okay, so we're going to compare the number of frames, the number of compares, the number of swaps, average number of swaps per frame, and the average number of compares per frame. This will be 0.6 float, maybe 2.6 float. Go with 3. It might actually be, well, the 0.6. All right. Okay. Tidy this up and debug it, just so you can see what I mean about the bubble sort being fast enough. Knowing that quicksort is a logarithm in 2, and it's, even in its best case, it's log 2, whereas this log n, whereas this will be, well, n log n. This one will always, this one in the best case will be n most of the time. N comparisons, most of the time it's going to be 0 swaps. So our average will be 8, 9 compares and 0 swaps on average. That's my prediction. Like I said, one special case coming up eventually. Unsigned, signed, whatever. I probably should be consistent, huh? Int 32. Uint 32. Small, mostly sorted data sets. Bubble sort's amazing. Okay. We run it. We hit play. We're just going to let things run for a little bit. So Saturn behind Jupiter most of the way around. Now Saturn's in front of Jupiter. Perfect. Okay, that's probably enough. Run the destructor. There we go. So we ran for 4 million frames. The maximum number of comparisons seems really high, actually. Max swaps seems very high for 9 items. On average, I'm not sure we logged that right. No, LL. Never mind. 44,000 frames, not LL. It's LLU. So ULL is wrong. Double long U. Swapless compares. So swaps compares. There we go. So max compares, max swaps. One index 2. It does seem like more than I would expect. That's changed equals true.
Do you still here?
Go ahead. Swaps and compares. We fixed the logging. Oops. Let that run for a few seconds. We do have things swapping around because they do change their order. So Saturn is going to be in front of Neptune coming around the corner. Okay. And it's stuck. What's it stuck on? That's not good. My solar system doesn't do anything that should prevent quitting. Assertion failed. I have a memory layout issue. There we go. Max compares maximum swaps. So on average, our swaps are less than 1 in every 100 frames. Average comparison, 36 times per frame. That's nothing. Although, what is going on with my memory? Do I need to do a full clean and debug build? Maybe debug, I think. Okay, but in journal, we do have taking our depth. Now faked by y coordinate. 1 sort per frame with bubble sort. This works well for small collections of mostly sorted data. Yeah, some memory somewhere got misaligned. Somewhere. I wonder if we have to use a mem copy instead of an assignment on that struct. You can. That might work better. How cute. We're going to change the periodicity of all of these. Mercury's going to be like 3 seconds. Neptune's going to be like a full minute. Okay. Quit. Yeah. Swaps compares really not that bad. And that's probably the first frame when everything's in random order. Because we picked a random T position. Yeah. Not bad. Not bad. Average number of compares 36. Anyway. Just for fun. Okay. Now. Now planets are sorted during their orbits. Okay, not too shabby. We don't need this anymore. Back. We don't need any of these anymore. Or these. Or this. Or those. Or any of this. There we go. All right, what's next in our journal? Stars. Stars. Oh, my stars. On screen, how big are the stars? We do know the width and height of the chalkboard. We're going to render those behind the planets. Visuals, too much alpha. Uranus rings are a little bit too alpha, except over the top of Uranus. So just like tiny cleanup things, nothing big. Okay. Stars. We should do stars. We should log just how big the stars are, or how big our chalkboard is. So when we set that size, this is actually going to go pretty well for our next thing. Now that we got that clipping, that actually works pretty well. Okay, so we want set bounds rectangle. how big to make the stars area. We actually kind of wanted to extend up towards the alphabet a bit. Width 0.3 float. The rectangle dot or width. No, we do want width. The question is how high. Don't I have like a pixel measurement something somewhere? Or I could use a screenshot I've got to do that, to measure. That might work. Okay, compile. Debug. Yeah, honestly, we are in good shape. Like I said, I figured 2 days for the solar system one. And like almost 4 hours of that was art, so code-wise, not too shabby. Width 874. Ooh, that's the kind of pop we don't like. And Saturn popped in front of Jupiter there. Basically, where the two of them cross, you want them to not be pixels overlapping. So we actually need to change the spacing of some of these planets. But the big yellow one is the sun. Okay, blah, blah, blah. 874. Over to the GIMP. Like I said, we'll have to do some things about some of this. So there's the sun. The big yellow one is the sun. We put that there. And come up from there 2 pixels. And then 2048 minus 874. 1174. So our stars are going to kind of fit in here somewhere. I need to know how tall. Let's open a file. I need to know. I think in branding is probably in screenshots. I don't have the screenshots. And I think I deleted the other thing. Shoot. Okay. I'm gonna launch the game. I'm gonna load in. So this is a full screen size. We're gonna print screen. Close that. Go back to the GIMP. Make a new one. 1920 by 1440, that's our size. Paste. Move the active layer. Yep, okay. This is it. This is our chalkboard. And the bottom edge is here. So you know about the clipping? Beautiful. Bottom edge happens right there. And I think we want to keep the stars below about there. So if we write down those two numbers, let's see here, where's my calculator? So if I hover here, that is 970 minus this number, which is 716. 254 pixels is our size. 254. So 1918 minus 254 is 1664. Sixteen 64. There. That is the size we can put stars. We're going to do a few things here, actually. This is going to be fun. I wonder if it would be easier for me to see. If we go bucket, white, oops. Yeah, then it's easier for me to see what I have to do. So we have to compare with both black and white because planets over the tops of planets. Okay, that's besides the point. We're going to stars. New layer. Star field. Rectangle. Oh, no, rectangle. Crop. Here we go. So there's the star field layer. Stars are going to be white. They're going to be tiny for, I don't know. Basically, these are like the foreground bright ones. Two. Okay. Then we're going to bump the opacity. There will be quite a few of these little tiny ones, I think. And then even more opacity. I really do want lots and lots of little tiny ones, I think. A variety of size and intensity, I think, that makes the stars look more like a star field. And you kind of don't want uniformity either. I think I'll try to create like a diagonal band with more. So it's like Milky Way. Even fainter ones. Whoa. Random scrolling for no reason whatsoever. Always fun. I don't like it when GIMP does that to me. Okay. All right, so that's the star field. Export. Export UVs. There we go. Okay. We're done with GIMP for a minute. Images and UVs. We have the star field. There it is. And it looks like it's about the right size. Delete. Okay. Star field is in. Re-embed our PNGs. Okay. Then in space.hpp, these are going to be more static-y things, so underscore star field will be fine. Star field dot set texture, image warehouse, asset, background and doodads, set UV, UV key, star field, set rectangle. We basically need this. We do not want to set center. Width, height, rectangle R. And underscore star field dot set rectangle 0, width, height. Okay, so there's that. Fade in. Update alpha of star field to alpha. Same for fade out. Okay, there's no update to be done on the star field. Render. Just that. Set bounds. M underscore star field dot move to. Our X is going to remain at 0. And our Y will be rectangle dot height minus underscore star field rectangle dot height. That should do it. All right, let's try it out. Make file. We do want image warehouse to rebuild. Okay, here we go. Hopefully the star field shows up and is beautiful. Then we check screen size variations. And probably have to call it there. Tomorrow, I have a couple of ideas. We'll do nebula. Nebula's fast and easy, relatively. We'll do some like twinkly stars. It'll be kind of fun, maybe. And then we'll add one more piece that I've been sitting on in the back of my head for a while. That should be a good day's work for Thursday. Star field data. Oh, we don't want to render the star field on top, though. That's not good. I want to do this like that. So that's unfortunate. We'll do another rebuild step once we're done with this. Oh, it might have been done in time. Oh, good. Load width. There we go. All the typos are out. It's going to build, and it's going to show up exactly where we want, exactly the way we want. Hopefully. Okay. Nope, I don't see it. Shoot. Oh, I know why. I know why. I'm pretty sure I know why. All right. Start making it a child of the right thing. Shoot. Starfield. This thing. Number of objects. We have to change that wording. Space. Number of children is 10. Because it's the number of objects plus 1. And up here, this is number of children. Starfield initialized as a child. Hopefully that just works. Let's just set up a parent-child relationship so the rendering is in the right place. Okay. Hey, there's some stars. I think we need more stars. But once there, it shows up, it works. Fades away. All right. Good enough. Save our work. Stars. Added a static star field. Needs more stars. Added a static star field. And there we go. So that's it for today. Or tomorrow we'll do a few more things on the space doodad, and then we'll see you tomorrow. Have a good one. Bye-bye.